Good morning, good afternoon, and good evening to everyone who joins us from around the world. We're so glad you're here.
It's really wonderful to be back here with you all.
This is Andrew and Renee. Welcome to the Stack series.
Yeah, and today is going to be a pretty wild journey. We are going literally and figuratively all over the place.
Today we are exploring the method of Loci, the neuroscience of navigation, and the future of memory technology.
From ancient banquet halls right up to virtual reality systems that basically read your mind.
Exactly. And honestly, looking at this stack of research today, I have to start with a little bit of a confession. Just some vulnerability right at the top.
Go for it.
I am historically, impressively terrible with names.
Oh, yeah.
I mean it. I meet someone at a party, they shake my hand, they say, "Hi, I'm Dave," and literally 3 seconds later, Dave is a total stranger. I'm just staring at him, panic rising, thinking, is it Dan? Is it Steve?
It is the absolute worst feeling.
It really is.
But you're definitely not alone in that. It's what we call the cognitive sieve. Most of us just live with it. We get bombarded with information every second of the day, and most of it just falls right through the mesh.
Right. But then you turn on the TV and you see these pop culture characters. You've got Sherlock Holmes waving his hands around, going into his mind palace to remember some obscure dust sample from 1890.
Yeah, or Patrick Jane in The Mentalist memorizing an entire deck of cards in a few seconds.
Exactly. It looks like magic. It looks like a superpower. So the core question we are tackling today for you, our listener, is this. Is this just a screenwriter's invention? Or is this a real trainable superpower that regular people, like people who completely forget Dave, can actually use?
Well, I can tell you right now, it is absolutely not just a trope. It's real. It's highly trainable. And what's really mind-blowing is that it's ancient. We are talking thousands of years old.
Which is crazy to think about.
It is. But even better, modern neuroscience, specifically research that won a Nobel Prize,
Yeah.
has finally shown us exactly why it works inside the physical brain. The way you remember facts is biologically bolted to the way you navigate space.
That specific connection was the thing that stopped me in my tracks while reading the sources. We have this massive stack of papers spanning Roman rhetoric, heavy brain science on grid cells, and then jumping into bleeding-edge tech like EEG brain scanning and AI.
It is a perfect collision of history, biology, and technology.
So our mission today is to figure out how our brains naturally map the world. Then, how we can hack that natural mapping system to remember pretty much anything. And finally, how technology is on the verge of taking those internal memories and splashing them out into the real physical world.
Which is thrilling, but also, slightly terrifying.
Oh, completely terrifying. We'll definitely get to that. So let's lay out the structure. We'll start with part one, foundations. That is what we think we know about memory palaces. Then part two, the active debate. Because the science is actually a little messy and experts disagree on some key points.
Oh, absolutely.
Then part three, frontiers. The sci-fi tech that is actually sitting in labs right now. And part four, implications. What all of this means for our ethics, our economy, and our society.
Sounds like a solid roadmap.
All right, part one, foundations. We have to start at the very beginning. And I don't mean like the 1990s. I mean 477 BC.
Yes. The origin story of the memory palace? It all starts with a Greek poet, a guy named Simonides of Chios.
Now, I read this account in the source material, and I gotta say, it is dark.
It's very dark.
It is way more gruesome than I expected for the origin of a cute little study hack. It reads like a true crime thriller.
Yeah, it's a tragedy, really.
Uh-huh.
But it led to this profound neurological insight. So, picture the scene. It's the 5th century BCE. Simonides is at this massive banquet in Thessaly. He was hired by a very wealthy nobleman named Scopas to recite a lyric poem.
So you have to imagine this grand, opulent hall. Big marble columns, giant wooden beams, heavy tables covered in food and wine. All the elite of society are there, drinking, laughing.
Exactly. And Simonides does his job. He stands up,
Yeah.
recites the poem for the crowd,
Yeah.
and then right after his performance, someone tells him there's a message for him outside.
So he just steps out.
Yeah. He literally just steps out the front doors of the hall, and the second he is outside, the entire roof of the banquet hall collapses.
Just completely caves in with no warning.
Total catastrophic failure.
Huh.
The massive stone roof and the marble columns just crush everyone inside.
And the sources note that the destruction was so absolute that the bodies were completely pulverized.
Right. Remember, this is antiquity. No dental records. No DNA testing. When the grieving families came to the rubble to collect their loved ones for burial rites, they couldn't recognize anybody. The physical trauma to the bodies was just too severe.
Which is just a horrific scene. Families crying, digging through stone, totally lost.
It was absolute chaos. But Simonides is standing there, looking at this flat pile of rubble. And he closes his eyes. He tries to visualize the room right before he walked out.
Okay.
And he realizes that even though the physical room is gone, the spatial map of the room is still perfectly intact inside his head.
Because he remembered the physical layout?
Right. He could see the head table. He knew Scopus was sitting right in the center. He knew the merchant was 3 seats to the left. He knew the general was near the pillar. So he opens his eyes, walks into the rubble, and just starts pointing. He identified every single body for the families not by looking at their faces, but by recalling their spatial coordinates in the room.
And that was the spark.
That was the aha moment. He realized that human memory is inherently spatial. If you arrange things orderly in a physical space, you can retrieve them easily.
And that realization evolved into the method of Loci. Loci just being the Latin word for places.
Exactly. It jumped from Greece over to Rome and became the absolute gold standard for Roman rhetoric. Guys like Cicero used it. Quintilian wrote extensively about it. You have to remember the context of the time. They didn't have teleprompters.
Right, or iPads.
Not even cheap paper. Carrying around a bunch of scrolls just to give a speech was totally impractical. So if you're a Roman senator and you need to talk for 4 hours about tax law or grain subsidies, you needed a reliable internal filing cabinet.
And the method of Loci was that cabinet. So let's break down the actual technique for our listeners. Because the sources give us a very clear 4-step recipe for how to build one of these.
Let's do it. And honestly, anyone listening to us right now can try this today. Step 1 is the loci itself. You need to select a familiar location. This is your palace.
But it doesn't actually have to be palace.
Oh, no. It could be anything.
Yeah.
Your childhood home, your current apartment, the route you walk your dog, your office. The only rule is that you have to know it so well that you can walk through it in your mind without exerting any effort.
So I don't want to use a museum I visited once.
Right. You shouldn't have to think, wait, where's the kitchen? It needs to be automatic. So let's say you use your living room.
Okay, I've got my living room, couch on the left, TV on the right.
Perfect. That's step 1. Step 2 is images. You take the abstract information you want to memorize, let's say a grocery list, just to keep it simple. You have to translate those boring list items into vivid images.
And the source material is very specific about this part. They say the images cannot be boring.
Boring is the enemy of the human brain. The technique uses a concept called elaborative encoding. You want the images to be bizarre, exaggerated, maybe a little violent or gross or funny.
Okay, so if I need to remember to buy pumpkins, I don't just picture a normal pumpkin sitting nicely on my coffee table.
No, your brain will filter that out instantly.
Oh,
It's too mundane. One of the examples from the sources was picturing a giant pumpkin violently smashed into a window.
Oh.
Yeah. Imagine the sound of the glass shattering. Picture the bright orange pulp dripping down the wall. Maybe imagine the smell of rotting squash. You want to wake up the amygdala. You want an emotional reaction.
Got it. Smashed pumpkin. So step 3 is placement.
Exactly. You take that crazy image and you mentally place it in a specific spot in your room. So maybe you place the smashed pumpkin right on your front door.
Okay. And then I move to the next spot for the next item.
Right. Say the next item on the list is milk. You move in your hallway. But don't just picture a milk jug. Picture a raging waterfall of chunky, sour milk flooding down your hallway. It's knocking over the family photos. You have to wade through it.
That is disgusting.
But you'll remember it. And that brings us to step 4, which is the journey. When you're standing in the grocery store and you need your list, you just mentally walk the route you created. You open your front door, you see the smashed pumpkin. Buy pumpkins. You step inside, you're drowning in sour milk. Buy milk.
Because the sequence of the physical journey preserves the sequence of the information.
Precisely.
Okay, so on the surface, this sounds almost silly. Imagine a pumpkin smashing a window. But why does it work so incredibly well? This is where we get into the heavy neuroscience, the hardware of the brain. Because for centuries, this was just treated as a neat magic trick.
Right. We didn't actually know why it worked until relatively recently. And it comes down to research by John O'Keefe and then later May Britt and Edward Moser.
And they won the Nobel Prize for this.
They did. The 2014 Nobel Prize in Physiology or Medicine. Let's start with O'Keefe's work in the 1970s. He was studying the hippocampus in rats. The hippocampus is this little seahorse-shaped structure deep inside the brain that we've known is related to memory.
Okay, so he's got rats running around in little enclosures.
Exactly. And he had electrodes recording the firing of individual neurons. And he noticed something bizarre. He found specific neurons that would only fire when the rat was standing in one very specific spot in the box.
Wait, so the rat goes to the top right corner and the neuron goes ping?
Yes,
The rat walks away, the neuron goes quiet, the rat goes back to the corner. Ping!
exactly that. He called them place cells. They are essentially the brain's "you are here" marker. They don't care about what the rat is doing. They only care about where the rat is. They bind an experience to a physical location.
So the hippocampus is literally drawing a map.
It is. But that was only part of the puzzle, because a map is completely useless if you don't have a sense of scale or distance.
Hmm.
You need to know how far corner A is from corner B.
Right, otherwise it's just random dots.
And this is where the Mosers come in. They were actually former students of O'Keefe. Decades later, they were looking at a brain region right next to the hippocampus called the entorhinal cortex.
And what did they find there?
They found what they called grid cells. And this discovery is just beautiful. These cells didn't just fire in one spot. As the rat moved around the room, a single grid cell would fire in multiple spots. And when the researchers mapped out all those firing spots from a bird's eye view,
Yeah.
they formed a perfect, symmetrical, hexagonal lattice, like a honeycomb pattern covering the entire floor of the enclosure.
That is insane. So our brains project a literal grid over the physical world.
We do. It is an internal biological metric system, like the latitude and longitude lines on a globe. The grid cells give you distance and direction. And nature chose hexagons because, geometrically, it's the most efficient way to tile a flat surface.
Like bees making a hive.
Exactly.
Yeah.
So if you put it all together, the grid cells in the entorhinal cortex provide the ruler, the distance, and the place cells in the hippocampus drop the pin on the map.
That is incredible. And this perfectly explains why the method of loci works.
It does. Think about human evolution. For millions of years, our survival did not depend on memorizing tax codes or the periodic table.
No, it depended on finding food.
Right. Where is the watering hole? Where are the poisonous berries? Where is the cave? We evolved a supercomputer in our heads specifically optimized for spatial navigation.
So when we use a memory palace, we are essentially hacking that ancient survival GPS.
We are taking highly abstract data that the brain usually struggles to hold on to, and we are converting it into a format spatial location that the brain is biologically hardwired to lock down. It's called dual coding theory.
Right, I saw that in the papers. So by using both verbal and visual spatial processing, we are double hooking the memory.
You're using twice the neural real estate.
That makes so much sense.
Okay.
So we've got the foundation, the ancient history, and the hard biology, and this is but as someone who has tried this technique, it is not easy. It takes a ton of mental energy.
It does, which leads us right into part 2, the active debate. Because a lot of learning scientists look at this and say, hold on, is this actually efficient?
Right, because sometimes I feel like I am spending way more brain power trying to paint the walls of my imaginary palace than I am actually learning the material.
And that struggle is what psychologists call the cognitive load problem. The sources dive deep into cognitive load theory, or CLT. To understand the debate, we need to quickly break down the 3 types of cognitive load.
Okay, let's unpack that, because this seems crucial for anyone trying to learn anything.
It's fundamental. Imagine your working memory is a bucket. It only holds so much water before it overflows. The first type of water going in is intrinsic load.
Intrinsic.
Yeah, this is just the baseline difficulty of the material. If you are learning basic addition, the intrinsic load is low. If you are learning quantum mechanics, it's high. You can't really change it without just dumbing down the topic.
Fair enough. It's the raw weight of the barbell.
Good analogy. The second type is germane load. This is the good kind of effort. This is the mental sweat of actually building the neural pathways, connecting concepts, creating schemas. It's the effort that results in actual learning.
Okay, so we want germane load. What's the third one?
The third is extraneous load. And this is the enemy. This is wasted mental effort caused by bad presentation.
Like trying to read a textbook with terrible font.
Exactly. Or trying to learn from a teacher who keeps going off on confusing tangents. Your brain is burning energy just trying to decipher the format, leaving less energy to actually understand the material.
So how does this apply to the memory palace?
Well, the critics argue that forcing a student to construct a complex mental building, maintain it in their mind's eye, invent bizarre images, and map a journey. All of that generates massive extraneous load.
You're juggling too many imaginary balls.
Right. You're spending so much capacity managing the interface that you might actually learn the raw data slower.
And this is where the tech comes in. Because the hypothesis from these researchers was, what if we use technology to offload that extraneous load?
What if the computer builds the palace for you?
Enter virtual reality. The sources highlight this fascinating study by Krogos and his team. They were comparing traditional desktop screens against head-mounted displays, or VR headsets.
This study is a major turning point in the literature. They wanted to test if physical immersion actually matters for memory. So they had participants try to memorize things in a virtual memory palace. Half the group used a standard computer monitor and a mouse, like playing a regular video game.
Right, you're sitting in a chair looking at a screen.
The other half put on the VR headset. They were visually completely inside the virtual room.
And the results were pretty definitive, weren't they?
Highly definitive. The VR users showed significantly superior recall. Depending on the specific metric, it was an 8% improvement up to a 30% improvement.
But why, structurally, they're looking at the exact same digital room. Why does strapping the screen to your face make the memory stick better?
Because of the vestibular and proprioceptive systems. When you sit at a desk and move a mouse, your eyes see movement, but your inner ear fluid, your balance system, knows you are completely stationary.
Your body knows you're just sitting in a chair.
Exactly.
Mm.
But in VR, when you physically turn your neck to look at a virtual table, the world moves in perfect sync with your head. Your proprioception, your brain's awareness of where your body parts are in space, is fully engaged.
So it tricks the brain.
Yes. It tricks the brain into believing you are actually physically present in that space, which means,
Fires up the play cells.
boom, it activates the hippocampus way more aggressively. VR provides the physical structure externally, so your brain doesn't have to burn energy imagining it. The extraneous load drops, and the memory retention spikes.
That is amazing. But looking closely at the sources, there's some nuance here. This doesn't seem to be a magic bullet for absolutely everyone.
No, and we have to be very careful not to oversell it.
Hmm.
The data on individual differences is really important. For healthy adults, it's highly effective. For the aging population, it's also very effective. It acts like weightlifting for the aging brain, leveraging neuroplasticity.
But what about clinical populations?
Right. The researchers did a feasibility study looking specifically at patients with schizophrenia. And they found that the method of Loci did not significantly improve their episodic memory performance.
Why is that?
Because the technique, even in VR, requires a solid baseline of stable attention and executive function. You have to be able to focus on the spatial anchor and the memory item simultaneously. If a condition impairs that foundational attentional stability, the technique falls apart.
So it's a tool, not a cure. If you can't lift the barbell, the exercise doesn't help.
Exactly. There was another really surprising caveat in the data regarding what kind of stimuli you were trying to memorize.
Oh, the words versus images thing.
Yes. The data shows that the method of Loci actually works much better for memorizing lists of words than lists of pictures.
Which feels completely backwards. If this is a visual technique, shouldn't pictures be easier to stick on the wall of your palace?
You would think so,
Mm-hmm.
but it goes back to germane load. The good effort. If I give you the word democracy, your brain has to work hard to figure out how to visualize that.
I have to turn it into a ballot box or a flag.
Right. That active translation process is what cements the memory into your neural network. You are wrestling with the concept. But if I just hand you a photograph of a ballot box
I just paste it on the wall in my head.
and you don't process it deeply, it's too passive. Passive consumption is the enemy of memory retention. The mental friction is the whole point.
Wow. So to our listeners, if you are studying for a test, don't just use flashcards with pictures. Force yourself to translate the concepts.
Absolutely. Get your hands dirty with the data.
Okay, so we've covered the debate over cognitive load, the power of VR, and the limits of the technique. Let's move into part 3, frontiers. Because the technology in these papers goes way beyond just putting on a headset. We're talking about smart environments.
The era of the bioadaptive memory palace.
The sources outline a system called Coglocus. And reading about this felt like reading a cyberpunk novel. Can you break down what this actually is?
It really is sci-fi stuff made real. Coglocus is a prototype system that combines a standard VR headset, like an Oculus, with an EEG device.
An EEG being the cap with the sensors that reads your brain activity.
Exactly. Specifically, the system is monitoring your beta waves. In neuroscience, beta waves are a very reliable proxy for active concentration, stress, and cognitive load.
Okay.
If your beta waves spike, it means you are thinking really hard, or you're getting frustrated and overwhelmed. If they drop too low, you might be zoning out or getting bored.
And the virtual room is listening to this data.
In real time,
Mm.
the system uses a parametric design software called Grasshopper. and it physically alters the architecture of the virtual memory palace based on your live brainwaves.
Give me a concrete example. Say I'm in my virtual palace, I'm trying to memorize the entire human skeletal system for med school, and I start getting really overwhelmed. My beta waves spike. What does the room do?
The room adapts to calm you down. The software might literally raise the virtual ceiling.
Raise the ceiling.
Yeah. Psychological studies show that higher ceilings promote a sense of freedom and abstract thinking. It relieves mental pressure. Or the system might notice your stress and decide to remove visual clutter. It lowers the furniture density. It dims the lighting. It dynamically reduces your extraneous load.
The room breathes with you.
That is the perfect way to describe it. It breathes with your cognitive capacity. And conversely, if it senses you are bored, it might lower the ceiling or add more complex visual geometry to wake your brain up.
That changes everything. It's not a static tool anymore. The environment is an active partner in your learning.
It completely sidesteps the cognitive load debate. You don't have to manage the interface because the interface manages itself.
But building these rooms still takes time, right?
Yeah.
Even in VR, someone has to code the room.
Well, they used to.
Mhm.
But that brings us to the next frontier, AI-generated palaces. Large language models paired with vision models.
Right. Because laziness is undefeated. Most people quit the memory palace technique because designing the palace is too much work.
Exactly.
Yeah.
But now you can just prompt an AI. You could say, hey, generate a 19th century Victorian library optimized for memorizing the French Revolution. And in seconds, it builds the 3D space.
And it can personalize it.
Hyper-personalization. If the AI knows you are a massive Star Wars fan, it builds your memory palace to look like the Millennium Falcon. If you love botany, it builds a greenhouse.
Because if you have an emotional connection to the space, the memories stick better.
Exactly. The familiarity breeds retention.
The sources also talk extensively about augmented reality, AR, and this view is fundamentally different from VR because we aren't leaving the physical world.
AR is a total paradigm shift. Instead of transporting you to a fake room, AR overlays the digital memory cues onto your actual physical reality.
So practically, how does that work?
Imagine walking down your actual street wearing AR glasses. You look at the coffee shop you visit every single morning, and floating right next to the door is a holographic tag with a complex chemical equation you need to learn.
So the whole real world becomes the canvas.
Yes. And the literature calls this one-shot memorization. You completely eliminate the need to train a mental palace. You just use the existing architecture of your city.
You anchor the data to real landmarks.
Right. You look at the bus stop, you see the date of the Declaration of Independence, you walk past the park, you see the Spanish vocabulary words.
There was also this really interesting interface concept mentioned called WIM, Worlds in Miniature.
Oh, WIM is brilliant for spatial navigation. One issue with VR palaces is that walking from the virtual kitchen to the virtual bedroom takes time. It's slow.
Yeah.
WIM solves this by rendering a tiny 3D dollhouse version of your entire memory palace that you can literally hold in your virtual hand.
Like a 3D minimap.
Exactly. You look down at your hand, you see exactly where all your data is stored from a bird's eye view, and you can point and teleport instantly. It helps your brain maintain the global map while you are down in the weeds looking at specific details.
That is incredibly slick. The potential for education here is staggering. But, and we have to pivot here into part 4, implications. Whenever we start talking about directly linking technology to human cognition, it gets extremely messy.
It always does. Technology is never neutral, and the ethical costs here are massive.
There was a phrase in one of the papers that honestly sent a chill down my spine. XR memory manipulations.
Yeah. This is the dark side of the tech. If we start relying on extended reality to store and access our memories, we are placing ultimate trust in the corporations that design the software. The researchers outlined 3 distinct classes of manipulation.
Let's go through all 3 because I think you really need to understand the risk we're walking into.
The first class is influencing quality. This means the system subtly changes how you feel about a memory.
How?
By altering the context. Say you access a memory of a vacation you took. The AR system could subtly darken the lighting or play slightly ominous background music while you review it. It colors your nostalgia. It makes a happy memory feel sad or scary.
You're outsourcing the emotional tone of your own life to an algorithm.
Exactly. The second class is inducing forgetting.
This one is wild.
It is. If the system decides it doesn't want you to remember something, it simply hides the retrieval cue. If you don't see the hook, You can't access the memory.
It's digital censorship of the human mind. Like, oh, we don't want you to remember the opt-out clause in this contract, so the AR just never displays the cue when you walk past the bank.
Precisely. And the third class is the most insidious, distorting memories. This is literal gaslighting via augmented reality.
Changing the actual content.
Right. Let's stick with the contract example. Say you clearly remember a document saying the user retains all rights. But when you pull up the memory cue in your AR glasses, the text has been altered to say the company retains all rights.
And if you see that enough times, your biological brain will probably start to doubt itself.
It will surrender to the digital record. Memories are fragile. If the AR tells you something happened differently over time, your brain rewrites the biological memory to match the digital one.
And human memory is the core of identity. If someone can manipulate your memories, they are manipulating who you are as a person.
Which brings us directly to the privacy and data security crisis. For a system like CogLocus to function, it requires a horrifying amount of continuous data collection.
It needs the EEG.
It needs your brainwaves. It needs constant eye tracking. It needs audio recording of your environment, your location history, your heart rate.
It's the ultimate panopticon. To have the perfect AI memory assistant, I basically have to surrender the total privacy of my inner biological life.
That is the Faustian jargon of this technology. Companies won't just know what products you look at. They will know exactly how your brain reacts to them. They will know when your cognitive load is high, meaning they know when you are confused and vulnerable to suggestion.
That is deeply unsettling. And it ties into another fear raised in the sources, cognitive atrophy, the Google effect on steroids.
Right. If the AI remembers everything for you and the AR glasses constantly guide you, does your biological hippocampus literally shrink?
Because it's a muscle. Use it or lose it.
Exactly. We have MRI studies showing that London taxi drivers, who have to memorize the incredibly complex map of the whole city, have physically larger hippocampi than average people.
So if we just stop using that spatial navigation system because the AR does it for us...
The fear is that the tissue could actually atrophy. We could lose our natural ability to navigate and remember.
But the authors do offer a counter-argument to that, don't they?
They do. They argue that we should view these tools as cognitive prosthetics.
Like wearing glasses.
Right. Wearing glasses doesn't make your eyes rot out of your head. It helps you function at a higher level. The goal of this tech shouldn't be the total replacement of natural effort. It should be targeted intervention.
So if we use the AR to offload the boring rote memorization, it frees up our biological brain power for higher-level critical thinking and creativity.
That's the optimistic view. But if we just use it to zone out and consume passively, we risk becoming completely dependent. We become tourists in our own lives, totally reliant on a GPS we don't control.
Wow. And the ultimate future speculated in these papers goes even further. Neural interfaces.
Direct upload. Bypassing the eyes and ears completely and writing data directly into the brain's spatial centers.
Blurring the line between biological memory and digital storage so completely that the distinction just ceases to exist.
At that point, if you download an entire memory palace full of knowledge in 3 seconds, the philosophical question is, did you actually learn it?
And does it even matter if you did? If you can access the information instantly, is there a functional difference between learning and downloading?
Those are the questions we are going to be forced to answer over the next few decades.
It is a lot to process. We've gone all the way from Simonides standing in the bloody rubble of a Greek banquet hall, realizing that location is the master key to human memory,
to the microscopic firing of grid cells in rat brains, proving that this is a hardwired evolutionary mandate.
all the way to virtual rooms that adapt to our brainwaves, and augmented reality that paints our knowledge directly onto the streets of our cities.
We are fundamentally shifting from passive recall, desperately trying to hold on to isolated facts, to active, immersive experiences of knowledge.
It seems like the future of learning isn't just about reading a book. It's about physically inhabiting it.
I think that is a beautiful way to put it. We are building digital worlds to hold our human wisdom.
Before we wrap up, thank you to all our partners, sponsors, and scholars who made this podcast and the research possible. We're truly grateful for your support.
And to our listeners, thank you for being part of this journey with us. We hope you enjoyed today's discussion. If you did, be sure to subscribe and support us on Patreon. And of course, you can write to us in comments if a specific topic needed to be covered, which help us all to grow.
Until next time, stay curious, keep learning, and let the search for wisdom guide you forward. Have a great day.